So this is what, let's review what we talked about yesterday. We talked about the different layers of the Earth, okay? We said the core is in the center, we have the mantle, and then the crust. And the core is the heaviest, right? It's got heavy metals like iron and nickel. The mantle is the middle part, and there's two parts to the mantle. So the asthenosphere, okay? The asthenosphere is the part where there's all the magma, and that's what the plates ride on top of. And then the lithosphere is the top part of the mantle and the crust. So that's what we talked about yesterday. We talked about how the plates are divided up among the continents and the oceans, and they're able to move because we get heat from the center of the Earth. So our compounds, some of our elements, are radioactive in the center of the Earth, and they're able to radioactively decay. So they decay, and when they do, they release heat. So remember we talked about the second law of thermodynamics. Whenever we get a change in energy, it releases heat, or it doesn't have as much usable energy after that energy is transformed. So in this case, when we get an atom decaying, it releases some of that energy as heat. And that heat drives magma upwards, and it forms these little cells or cycles, okay? We also talked about how there are oceanic plates and continental plates. Which ones are heavier? Oceanic plates, okay? So we talked about the two types of plates, and then we talked about hot spots. And a hot spot's just the area where the lava reaches the surface of the Earth, okay? So we're going to talk about plate boundaries today, so different plates. But in order to do that, we have to talk about what happens when plates end up colliding with each other. So one of the plate boundaries that you saw yesterday was convergent, okay? And so one of the words that we're going to talk about before we talk about this boundary is subduction. That just means one plate goes under another. This happens quite a bit. And if we think about our plates and our oceanic plate being heavier than our continental plate, our oceanic plate, because it's heavier, is going to be the one that goes underneath. So they call this a subduction zone, right, where one plate's going underneath. And then as a result, what we get usually, we'll talk about this in a second, but we usually get kind of like a trench over here. You see this little trench, and then we get a volcano, okay? The reason we get a volcano is because when this plate goes underneath, it gets heated up, okay? And when it gets heated up, it turns into magma, and then that magma rises up into that volcano, and then the volcano erupts. So this is how we get volcanoes. Volcanoes are just areas where that lava reaches the surface, and it's typically when it moves, when these plates move over an area that has magma already coming up, when it moves over a hot spot, okay? So we have to have magma kind of coming up here so that it can melt the plate and then create that magma for the volcano. So as the plate then moves over this hot spot, right, like we found a hot spot in the area where the magma comes up, heat from the mantle melts the plate or melts the crust, and it forms a volcano. And a volcano by definition is just a vent, right, where we're releasing magma, ash, gases, etc. And they can form at any type of plate boundary. So we're going to learn about the different types. You guys saw yesterday convergent, divergent, transform. Okay, so they can form at all different plate boundary types. So let's talk about different types of plate boundaries. Okay, so a divergent, okay, to diverge, right, means to go apart. So a divergent plate boundary is when the plates move apart from one another. So two plates are going to move apart from each other. Okay, and what happens is if this is an ocean, we get the magma coming up, and as that magma hits the water, it's going to cool. Okay, so we have new magma coming up, it cools, and so it kind of creates like a new part of the plate, new ocean floor, and then the plates move further apart, and more magma comes up and it cools, and the plates move further apart, and more magma comes up. And so we call this seafloor spreading, and it's actually making new seafloor. Okay, typically divergent plate boundaries, as we see, they don't really happen in continents, they just happen in the ocean. So we'll look at those, we'll look at a map and see where they happen in a second. So if we look at this map, okay, spreading zones are in red. Where do we see a lot of them? Spreading zones, where are the red lines? In the oceans, right? So what you can write down on your note packet is that where are they found? Typically in the middle of oceans. Okay, so what the AP exam likes to do is they like to give you a map and ask you questions. So they like to give you a map and like put a dot here for A and a dot here for B and maybe one here for C and be like, where would you most likely see seafloor spreading? Or where would you which area would have the most rapidly growing population? Okay, they like to do that. So if we're talking about places in the world, right, we would say spreading typically happens in the middle of the ocean. So two places moving apart diverge. Now we have convergent. This means to come together. So this is when we have two plates move toward each other and they end up colliding. And there's two different things that can happen when they end up colliding. So the first thing that can happen, it depends on if we have two continental plates colliding or if we have a continental and oceanic plate coming together, okay? So if we have two continental plates, remember they have roughly the same density, they weigh about the same, okay? So when they collide, they're actually going to hit each other and kind of form upward, okay? And they're going to form like a mountain. Now if we have a heavier plate and a lighter plate, like a continent and an ocean, right? When they collide, one of them is going to go underneath the other one. So the first one is two continental plates, okay? And both plates are going to end up like lifting, and it typically forms a mountain range in the middle of the continent. This is where you see mountain ranges that aren't by any kind of like coast, they're just in the middle. So the Himalayas in Asia were formed this way, with two continental plates coming together. We don't typically have two oceanic plates coming together. Don't ask me why, I have no idea, but apparently that doesn't really happen. If we have a continental plate and an oceanic plate coming together, the oceanic plate subducts or goes under the continental plate. So then what we end up seeing is a trench forming on one side. So we get a trench here, and then we get volcanoes over here, and it's called a volcanic arc because we get a whole bunch of volcanoes along the edge of that trench. Okay, because this plate's going underneath, it's creating magma, and then it's erupting as a volcano. So if you see a whole line of volcanoes, a lot of times we'll see like a whole line of volcanic islands, it's a pretty good guess that that might be subduction or convergent plate boundary where one plate's going underneath another. So if they're converging, they're coming together, one plate's going underneath the other. Okay? So what are some examples of volcanic arcs, right? Areas where there are lots of volcanoes. We'll see a lot of them in the Ring of Fire. So the Ring of Fire is basically a big bunch of subduction zones where one plate's going under another, and it's all around the Pacific. So notice it's around Australia, right, and China, through Alaska, South America, the US, and this is called the Ring of Fire. And the reason it's called the Ring of Fire is because it's responsible for a ton of earthquakes, tsunamis, and volcanoes, because these are all subduction plate boundaries. This is a big plate here. It's a big oceanic plate, and what happens is when it hits these other continental plates, it's going underneath that, and it's creating a lot of volcanoes and earthquakes. So some examples, you'll see the Caribbean, there's one right here, it's a tiny one, but that's an example. All these little islands were formed from volcanoes. Some of them still have active volcanoes, some of them are still not active. But a lot of times when you see a lot of little islands in a row, it could be a good indication that it's a volcanic arc. Same thing here. The little triangles are all of the volcanoes. This is off of the coast of Alaska. Okay? So these are examples of volcanic arcs. And if we look at this, where exactly do they happen? Well, we saw the Ring of Fire. Okay? We also see some over by Europe and Asia, but mostly it's the Ring of Fire. Okay? All right, last one. If we don't have plates going away from each other or towards each other, they can be sliding past each other. So plates move sideways past each other along a fault or along that space in between those two plates. Now, when they slide past each other, they typically cause earthquakes. And the reason they cause earthquakes is because when they slide past each other, they end up like rubbing, And they pretty much, they're under a lot of tension, and then when they finally move, that's what causes an earthquake. Think of like a rubber band that's like stretching and stretching, and then all of a sudden you release it. That's what an earthquake is. It's a release of energy. So there's a high level of earthquake or seismic activity. For example, the San Andreas Fault in California, right? You hear about a lot of earthquakes in California. All right, so here's what we're going to do. We are going to, if your last name is A through F, what I want you to do is take about like 6 or 7 minutes and look up earthquakes, okay? What I want you to look up is what are the impacts, okay? You can look up impacts to humans, but I also want impacts to the environment if you can find them, because what happens is a lot of times on like, I haven't really seen a free response. I haven't read through all of them, but I could see them asking you, like, oh, what would be one impact to ecosystems, or how would earthquakes impact ecosystems, like on a free response. So I want you just to understand like the consequences of these and what actually happens with these different types of phenomena and how they affect the environment. So maybe talk about if you find something on like water supply or organisms or habitats, how do they affect those? So use your phone or a computer. You can write down your answers. You're just doing one. Write down any answers you find in your note packet, and then I'm going to call on people to share out in like 5 minutes, okay? All right, Cameron, Cameron, you had volcanoes, right? Yeah, what did you get once one effect? Good, okay. So CO2 releases CO2, which is a greenhouse gas. So you can fill these in as you go. Sarah, you had tsunamis. What did you get? What's one thing? Okay, so tsunami is a big wave. It's a big tidal wave, right? So they can cause flooding to the landscape. Good. Brittany, what's one thing you got for earthquakes? Good. So landslides, which could destroy habitat for humans or for organisms. Cassidy, what's another thing you got for volcanoes? Good. So they also release sulfur gases, which can lead to cooling, which actually, so they do release carbon dioxide, but volcanic eruptions actually cause the earth to cool. So if there are a lot of volcanoes that are really active, they actually cause the earth to cool. And they actually think that some of the ice ages were caused by a ton of volcanoes erupting, because what happens is when they spew ash into the air, the sulfur and the ash reflects and prevents light from coming in, and then the sulfur acts as a cooling gas because it also reflects light, and as a result, it causes the earth to cool down a little bit. Now, if it's one volcano, it's not really going to have a big impact, but imagine if you had a whole ton of volcanoes at one point, it would have a pretty big impact. All right, she's not here. Autumn, what did you get? Do you get anything else for tsunami? Yep. Okay. So damages buildings or homes. Could also damage habitat, right? Because we're flooding. Find somebody else to do. Vince C, what else did you get for earthquakes? Sorry, say that again. Okay, so it causes big faults or cracks in the earth, which could damage buildings, faults or cracks, which could lead to damaging buildings. So I'll show you what I have, some things you don't need to worry about, like, I mean, write down the ones that seem good to you. You don't need to worry about like memorizing every single one, but if somebody were to ask you, you know, which one of these could be an impact, right? I would want you to be able to figure it out. So I want you to at least hear all of these. So earthquake, you don't have to write down epicenter. That's the point above the surface where the earthquake happens. The Richter scale actually isn't used to measure earthquakes anymore. It's an old scale, so don't worry about that. I don't think you will ever be tested on that. And if you do, you can tell me, Ms. Frankson, you were wrong. What the heck is an earthquake? Well, like I said, it's the release of energy. And typically it's caused by plates sliding against each other. So how does it impact the environment? With earthquakes, it can collapse buildings. They can easily start fires. Contaminating water supplies. So if you think about it, we've got a big crack in the ground a lot of times, and if that contaminates either pipes bursting, right, or it's contaminating the groundwater because now we have this big gaping hole open to our groundwater that's supposed to be clean. So it can contaminate water supplies, causes dams to rupture. Imagine if you had a big dam and it ruptured, that would probably not be a good thing. It can be harmful because it can compromise power plants, right? So if we can't generate power, that could be detrimental to humans. Obviously, it can cause deaths from collapsing buildings, buildings falling on people, or just landslides. Volcanoes, okay, again, organisms can die due to inhaling, right? So reducing air quality is a big one because there's a lot of toxic gases. When I visited a volcano 2 summers ago in Nicaragua, they have a 30-minute limit. You drive up, but you can only be up at the top of the volcano for 30 minutes because there's a lot of toxic gases and they can have adverse health effects if you're up there for a long time. It can also release gases like sulfur that cause the earth to cool down. So yes, they do release carbon dioxide, and they also release sulfur dioxide. And then last but not least, before we go to that, this is showing you they did a computer simulation. Red is if there weren't any volcanoes. Here's how the temperature is predicted to fluctuate. Okay, and then they made a computer program and they said with volcanoes, here's what we would expect. So if there's like a big volcano eruption here, right, they would expect after that the temperature to drop, you know, almost 1.5 degrees Celsius because of that volcano eruption or because of the number of volcanic eruptions that happened that year. So again, these are just predictions. They're not predictions like, oh, in 2040 there's going to be a huge volcanic eruption. They're just saying if there happens to be one, this is what we would expect the temperature to do. All right, last but not least, a tsunami. What the heck's a tsunami? It's a big wave, okay? So what happens is the plates move, maybe one plate moves under another or moves up, and as a result, if you push something up, like in the ocean, that water gets pushed up and has to go somewhere, and it creates a big tidal wave, okay? Typically caused by, you know, an earthquake or plates moving underwater. So loss of coastal habitat, right? It could destroy reefs, coral reefs. Somebody asked me last hour, what's the difference between a typhoon and a tsunami and a hurricane? So a typhoon and a hurricane are the same things. A typhoon is in the Pacific Ocean, and a hurricane's in the Atlantic Ocean. They're the same thing. And the tsunami is just a big tidal wave. So the last thing I wanted to show you, I thought this was pretty cool, is it is a guy going to the inside of a volcano. So it's only 3 minutes. We're just going to watch this guy. He sacrificed his drones to go inside of this volcano, and I just thought it was fun.